All right, ladies and gentlemen, boys and girls, today we're going to spend some time talking about the modern atomic model. All right, kind of the objectives for this video here and this lesson today is to talk about what does the model of the atom look like according to what we know today, and then of the things that make up that atom. All right, what is the three things? What are their charge, their mass, and where we find them in the atom. All right, so we're going to be drawing a little bit of chart. We're going to draw a little bit of a picture here today. I highly recommend if you have colors to kind of use that and color code this today. It's going to be really, really helpful. All right, so let's start back in the beginning here. All right, the atom, right, is the fundamental particle of matter, which basically what that means in kind of simple terms is everything is made out of. If you took any object in the universe, you broke it down, you cut it down into its smallest pieces possible, all right, until you couldn't cut it down anymore, we would be talking about the atom. And now we are talking at a scale that is extremely small. So small that it's very hard for our brains to imagine it. So small that even our most powerful microscopes can't see them. All right, we see kind of fuzzy images, but that's the best we've been able to do with it. All right, the periodic table is a diagram that shows all of the different types of atoms that we know. And it's funny because there are different types of atoms, but each atom, even though there's 118 of them, are only made up of three things. It's just about the number of those three things that determine it. All right, so let's first start talking about what we think today the modern atom looks like. All right, and that has changed a lot, all right, throughout time. In fact, we used to think that the first idea or the first atomic model looked like this. All right, a very simple ball or sphere. This was created by John Dalton. He called it the billiard ball model because it kind of looked like a ball from pool or billiards. And it was very simple. He was the first one to come up with the idea of maybe the structure of an atom. He was the first one to coin the idea of an atom, but he was the first one to put some kind of scientific evidence behind it. Now, it has dramatically changed since our atom of what we used to know about 250 years ago, because we have more and more technology, the more we understand. No one scientist knew the answer. It was always just building on from one scientist on their ideas. They try something new, they try something new, trying something new. And even when we say the modern atomic model, I say modern because I didn't write the right answer, because we don't know. We're learning more and more all the time. But we're pretty confident with the data that we have right now. This is what the atom looks like. And it's made up of three parts. All right? Every single type of atom, whether it's a gold atom, an iron atom, a hydrogen atom, a neon atom, an oxygen atom, they're all made up of three things. And it's just about the number of those things. All right? And so we're just going to talk about kind of a general picture of an atom here. All right? And so one of the first things that we know about, and probably one of the most important things because it identifies the atom, is that in our atom here, we have basically two parts. We have this kind of center part, and then we have this part around it. All right? And one of the first things that we notice in the very center is this very dense positive charge. That very dense positive charge, draw a little circle. It might be a little hard to see. I put a little plus sign in there. All right? The center of our atom is made up of these things called protons. All right? They're made up of these little things called protons. All right? So I'm going to kind of go back and forth between my picture and my chart. All right? The first subatomic particle, atomic being atom, subatomic parts of an atom, all right, is the proton. All right? The proton, all right? And it is in that center area. It has a charge of +1, all right? It has a positive charge. One way to remember that is the proton has a little T in it. There's a T which looks like a positive sign. All right? I'm going to come back, and it is located in the center here. I'm going to come back to the mass. I'm going to come back to the mass and location on each one of these. All right? So we have the proton. All right? in that or holding that proton. Now these protons are positively charged. Now let's think back to magnets here. All right, if you had two magnets and you put two sides that are the same, they're going to repel each other. They're going to repel each other. They're not going to stick together. Remember, opposites attract and similars repel. All right. So if I put a bunch of protons next to each other, they're going to want to bounce away from each other. All right. They're going to want to go in different directions. All right. And so our model also knows that there's something else in this center of the atom. All right. And we think that those molecules are something called neutrons. I'm going to use green for them. And these neutrons almost act like kind of like a glue. All right, the glue to kind of hold these together here. All right, these are neutrons. The neutron. All right, and they have zero charge, or they are neutral. It's easy to remember. Neutron, neutral. All right, and they are also found in this center part here. All right, and they're kind of holding the protons together, make sure they're not repelling off in different directions. All right, so what we have right now is we have our protons and neutrons in this very, very dense center. I'm drawing it kind of big because I'm trying to let you guys see it, but understand, if this is the picture of my atom here, this center part that I'm drawing so far would be very, 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 very tiny. Be very, very tiny. All right, but it is very, very, very dense. All right, it's where all the mass is going to be. This center part that we've created so far is what we call the nucleus. All right, so we have the nucleus so far. Nucleus just means center, right? And so we have the nucleus here. Then what we have going around that nucleus is our third subatomic particle. All right, the electron. And the electron, which has a negative charge. Has a negative charge. All right. Now this one was a little bit more of our more recent understanding. Is Bohr originally thought that they were these like very specific circles around them. We've seen that kind of picture before. All right. What we now know is actually that electrons kind of move not in very specific paths like we see kind of in models. I think we're all pretty familiar with the picture that looks something like this. All right, it might look like something like that, where these electrons are going in these very specific paths or orbits. We find that's not actually true now. We find that electrons move kind of almost in these kind of fuzzy, cloud-like regions around the cell. And I'm just drawing these as like little dots here, not because each one of these is an electron, but this is an electron cloud. All right, there's this kind of this region where electrons could be in, and they actually go in different energy levels. So here's kind of one cloud-like region that electrons could be in, and here's another cloud that electrons could be in. And depending on which element you're talking about, which atom, a gold atom, a silver atom, a fluorine atom, you're really determining about how many these are, which we'll talk more about. All right. So what we have here are what we call the electron clouds. All right. In there are little electrons zipping around all over the place. I'm drawing little E's for electrons. They're zipping around all around inside this cloud, kind of all over and within these certain energy levels. All right. And like I said here, obviously my blue ones are my protons. green one is my neutron. And then this whole center part here with the protons and the neutrons is what we call the nucleus. So we find the protons and neutrons in the nucleus. All right, so let's go back over to our chart here. All right. So let's talk about the location and the mass here. I'm actually going to talk about the location first. All right. So I have my atomic model here, right? Also known as the electron cloud model, where we have protons and neutrons in the center, and electrons floating around in these clouds. So where are the electrons, or where the location of the electrons is outside the nucleus or in the cloud. Or in the cloud, I would accept either one. All right. Neutrons, they are in the nucleus. And protons are in the nucleus. Okay, so I wanted to end talking about mass because there's a little extra part to this here. All right, so we're talking at scales ridiculously small. We're talking at the smallest thing that makes up everything. All right, and that's what these atoms are. All right, so the idea of using pounds, if we're using the English system, or grams if we were using the metric system, just didn't make sense. We're talking at things that are so ridiculously small that using grams, we would be talking about numbers so small so often that it just really wouldn't make a lot of sense. And so scientists did is they created a whole new scale. These are so small that we had to create a whole new measurement scale just to measure the mass of these things. All right, and they used the proton as the standard for that. All right, and a proton is something, or has a mass of what we call 1 AMU, or AMU. I'll write it up here. Is atomic mass unit. It's the atomic mass unit. So the proton is one of those. All right, so right now, I have 1, 2, 3, 4. That's 4 atomic mass units. So we're talking about a scale that is so small, we had to create a whole new unit for it, the AMU. All right, a neutron has a mass of 1 AMU. All right, so you should see a lot of similarities between protons and neutrons. Both are in the nucleus, both have the same amount of mass. The only difference is their charge. All right, so right now if I looked at the mass of this nucleus, I see 1, 2, 3, 4 protons, 1, 2, 3, 4, 5, 6 neutrons. That's a total of 4 AMUs plus 6 AMUs. That has a mass of 10 AMUs. All right. All right, 10 AMUs, because I have 10 protons and neutrons in my nucleus. All right, last one. I'm going to finish it up here. All right, is the electron. We had to create, or because protons and neutrons are so small, we had to create an entirely new scale. Even in that new micro scale or micro unit that we have, the atomic mass unit, electrons are still even almost too small for that. All right. The mass of an electron, right, is 1 over 1,836 AMUs. It's extremely small, right? I think it's 0.000026 AMUs, something like that. All right, it is extremely small. All right, so what I like to call this one is almost zero, or and spell that right, negligible, or almost zero. Not zero. It can't have no mass. It has to have mass because it is made of matter, But it is so small that it's insignificant. So if I said, what is the mass of this atom? All right. Okay, my 10 AMUs in the nucleus, and then let's say I have 5 or 6. The mass of these electrons are so small, I wouldn't even count it towards it. All right? It is so small that I would just say the mass of this atom, protons, neutrons, and electrons, is 10 AMUs. Because that number is so small, the mass of the electrons. It's one of the smallest things that we know of in the entire universe. All right. Okay, so again, the key was, do you know how, or could you label and draw the electron cloud model, knowing what each part is? And do you know the charge, mass, and location of the 3 subatomic particles, protons, neutrons, and electrons? Those are the objectives. If you do not know these things, you need to go back and fix these and put these in your handy-dandy notebooks. All right, so this video was a little bit long, but it was kind of 2 different things and kind of a big deal if you're talking about atoms. You got to know what they look like. All right, so otherwise, that should be it. Thank you very much. Good luck, and may the science be with you. Bye.